because I haven't been here, so I need you to tell me what we've been doing. So what about sampling? What about populations? Who can like paraphrase what you've done? Bella, give me a little bit.
We learned about samples and population.
So what's a sample? What's a population?
A sample is a piece of the population, like a part of the whole group.
Ugh. All right, keep going.
And then the population is the whole thing.
Population is the whole thing. A sample is a little part of it, or a piece, or a group.
And then
What else?
We learned about the parts of like the different types of samples.
So what do you mean the different types of samples? How can we sample?
Well, there's bias, like sampling.
What is bias?
When you ask like a specific group or like a type of thing, but you know that you'll get like one kind of answer because you're asking.
Yeah, so if I walk into a sushi restaurant and say who likes sushi, right, that's going to have a bias. All right, let's move on to somebody else. Sorry, you've done an amazing job. Just don't want to let you run the whole thing. What else? So once we started talking about bias, what's the type of sample you guys talked about yesterday? It's the easiest way you can sample. Thomas?
Convenience sample.
A convenience sample. What does it take to be a convenience sample?
It's like I see Ethan, Layla, and Oriana, and I ask them, do you do something?
Yeah, so it's what two things? They have to be
Convenient.
convenient.
And,
Starts with an A.
affordable.
Nope.
Available.
Available. So for a convenience sample, you have to have people or items. What's one item from your population called? Starts with an S.
Subject.
A subject. So if you are in a science experiment, you are a subject. Like some of you guys helped in the 8th grade science fair, you were a subject in their experiment. So in a sample, it's the same thing. One person is a subject. So those subjects that are convenient and available will create a convenient sample. But there's almost always an issue with the convenient sample. Well, okay, maybe I said that wrong. Not almost always, but oftentimes you'll run into an issue by choosing a convenient sample. And Bella talked about this a little bit already. Thomas, do you know what that issue would be?
Bias.
Bias. When you take a convenient sample, there's often a bias. So let's think about this situation here in the launch. Your school holds a school-wide kickball tournament. Your gym teacher lines up the class, starts picking every third person to make up the team. Have you ever had people do that before, like 1, 2, 3, 1, 2, 3? You know, like they count, and every third person they say you. So what's a benefit and what's a drawback to this sampling approach? Okay, Bunger?
A benefit is it's mostly random, but a downside is someone could like line up in a certain way so they do get picked. And
Yeah.
then there's a really good group, and then there's a really bad group, and then
If
then
you
the bad group
know, yeah, exactly what Ethan just said. If you know what like how somebody's gonna choose. If I told you I'm gonna choose teams every other, and I told you to go line up, a lot of you guys are probably gonna try to line up like not next to the person you want to be on the team, but like every other from the person you want to be with because you know it. So that is a possible drawback. But like he said first, it's mostly random. If I just tell you line up and I don't tell you how I'm going to choose the sample, then it is mostly random because if I choose every other, every 3, or every 4, I am not choosing the people. And if I was the coach, it's easy for the coach. He doesn't have to make any choices. He just says 1, 2, you, 1, 2, you, 1 to every third person. He'd just pull them out. So there are benefits and drawbacks to that. So let's say you want to take a sample of Phoenix students and you want to do a method like that. You want to choose every second or every third or every fourth, something like that. Can anyone think of a way that this would be really easy to do?
every fourth person you see in the hallway or something.
Every fourth person you see, I'm going to make it even easier than that though. What if you wait as people get off the bus or as people walk in the front door? If you stood at the front door and said, all right, 1, 2, 3, all right, give me you. 1, 2, 3, give me you. That'd be easy, right? Everybody's walking, essentially, they're coming to you if you wait at the front door. So this new sampling technique we talk about is called systematic sampling. So systematic sampling, I'm going to get your notes pulled up, the PDF real quick. A systematic sample is any sample found by using every n number of people. So every second would be every 2, n would be 2. Every third, n would be 3. So here in your box, you want to write that systematic sampling, like it says right up here. You don't have to write the whole thing, but it says, is a sampling method in which you choose every nth member of the population. N is a predetermined number. So here on your notes, choose every nth person is really all you need it to say. So choose every nth person. Choose every nth person.
Does N stand for number?
N would be any number that you decide. So you could choose every second person, every third person. Now what would be the issue if I said, I'm going to systematically sample Phoenix students, and I'm going to choose every 30th person? There wouldn't be that many. Yeah, Cassidy, because if I choose every 30 people, I don't have that big of a population. If I choose every 30, the first 30 people I get 1. The next 30 people, I'd get the 60th person. Then I'd get the 90th person. Then I'd get the 120th person, the 150th person, and then I'd run out of students. I'd only get a sample of 5. Now that could be okay, depending on what I'm trying to sample, but it might end up too small. All right, so then we want to assign numbers to our people. So the first thing that you would do if you were that gym teacher is have your students do what?
Line up.
Line up, right? So we tell our population, hey, you guys need to line up. This is not doing what it's supposed to. The interactive thing is not showing, so I need to go through this way. It may have logged me out, or it may just be having a glitch this morning. So on your paper, I want you to number all your people.
And I will assign each member a number so I know how many members are in the population.
I can't get her to stop, I don't think. Nope. So, did you number all your people? Yeah. Now we got to decide an interval, like every second, every third, every fourth, whatever we want to do. So here, we're going to use the interval.
There are 20 members in the population. I want a sample of 5 subjects.
So if you want
The interval n equals the population size divided by the sample size, or 4.
you take your
Divide the
population
sample
size,
into
divide
groups
it by
of 4.
your sample size, and that gets you your interval, or how many, like every whatever person. So what are we going to choose here? We're going to choose every fourth person. So you can go through, and I want you to write this on your paper, population over sample size, because that's how we find our interval. So to choose your interval, that's why we call it n, interval, n. We do population size over sample size to make sure that this gets on your paper. That's how we get 4. So now go through and circle every fourth person. 1, 2, 3, 4. 1, 2, 3, 4. It's also going to end up being the multiples of 4. 4, 8, 12, 16, 20. Do we have our population size of 5? Mm-hmm. Does our population seem to be mixed? Mm-hmm. Yeah. But
It's mostly blue.
we got 3 blues, 2 greens, and no purples. But that's okay because I systematically chose this sample. So even though I'm missing a purple, it's okay because I used a system to choose this. I did not have a bias when I chose it. I just chose every fourth person. So then they tell me that step 3, I want to find the starting point.
The interval n
we can start
equals
wherever
4.
we want, actually.
Pick a starting number between 1 and n at random.
And then go every 4.
The starting number
Here, they
equals
decide to
3.
choose- or they decide to start using the third person. So notice, who I start with doesn't matter, but then I have to go every 4. So we started with the fourth person. If they start with person 3, check out how
Start with the third member and then count every fourth member of the population after that.
7, right? Because 3 plus
1,
4 would give us
2,
7.
3.
So we choose person 3.
1,
4 more.
2,
We choose
3,
person 7.
4.
We'll go 4 more.
1, 2, 3, 4.
15.
1, 2,
19.
3,
So,
4.
however you want to do this,
1,
just choose a starting
2,
point, and then
3,
go 4. Choose
4.
that person, then go 4. Choose that person, then go 4. Choose that
Members
person.
3, 7, 11, 15, and 19 make up a systematic sample.
Well, now I think I can talk. If you're watching the videos, my apology that Misadventure's probably been screaming at you. It's really loud when she talks, and I can't mute it on here. So, your starting number was 4 when we circled it the first time. Their starting number did 3. We could have started with 2 or 1. It doesn't matter. Questions? This method is one of the easiest ways to get rid of bias or account for bias. So notice if you read the learning target when you came in, it's I can determine a way to systematically sample to account for bias. Because if I know that there's bias in the group, the way that I can not get rid of it, but I can account for it is just say, okay, I'm going to choose my people using this method, and you have to stick to that method. Did you guys talk about random sampling yesterday? Mm-hmm. What's a way to randomly sample?
Just pick some.
What's the, we normally say you draw names out of a hat, right? That's just kind of like, it's just something that we say. Yeah, you could put them in a boot. It doesn't matter. That's just like people say draw names out of a hat because they used to, almost everybody would wear a hat to protect their heads. So you take off your hat, put everything in, and mix them up and pull them out. So that's where the whole draw them out of a hat came from. So let's think about, are these systematic samples? Take a second on your paper. I'll give you about a minute. Decide if each of these is a systematic sample. If it is not, explain why. If it is, underline the part that makes it systematic. If it is, underline the part that makes it systematic. If it's not, explain why it's not. You have a minute starting now. By the way, we might have a mini mastery tomorrow. And by might, I mean probably. But mini mastery, meaning you're going to grade it yourself, is just a checkpoint. It's just a check-in. But we'll probably have a mini mastery to start class tomorrow. So I never like to give you pop quizzes, so we might have a mini mastery.
I have a question. I know people are going. How many lessons are in like this chapter?
We're almost. There's 8. Well, 7, and then there's the review, which will be optional, but there's really 7. So we'll do 5 tomorrow. We'll do 6 and 7 early next week, and then we'll take the mastery. And then we're gonna pause and do some SLO work, like what you've been doing for the other classes. I'm gonna have a Quizlet. So, guys, I gotta catch up a little bit with everything going on, the funeral and all that. I've just been spending a lot of time with family, so I've got papers to grade. I've got a lot to catch up on. So Monday when we come back, I'll have tons of stuff to get back to you guys. All right, so I gave you even more than a minute. Make a list of the students in your class and choose every 7th name starting from the first name. So, Layla, what do you think? Is that systematic?
Yeah.
Why?
Because you have an interval.
Yeah, so what would I underline here?
You choose every 7th name.
Choose every 7th name. That's your systematic. And then you gotta have a start point. You start from the first name. Now you could just start from the 7th name and then make it easy. It'll be multiples of 7. But if I start from the first name, then I would choose person 1. Who would be my next person? 8. Who would be my next person? 15. 22, and it would keep going.
29.
The ... means it keeps going. Divine, what do you think? You have the students in your class count off by 4s. You choose the students who counted 3s. No? So let's think about this. If I say, all right, count off by 4s, I'm only going to take the 3s. 1, 2, So you get chosen. 4. 1, 2. You get chosen, Katie. 4. 1, 2. Zach gets chosen. 4. 1, 2. Thomas gets chosen.
Yeah, I'm a special
Is this
boy.
a systematic way to choose people? Yeah, there's a system in place. So because we counted off by 4s, that tells me that my interval is 4, but I start with the 3. So my start point is 3. So instead of saying 3, 7, 11, 15, instead of doing that, you just had them count off. But it is still systematic. So yeah. You make a list of the students and choose the first 10 names on your list. Crystal, what do you think? No? Why do you think no? Yeah, what kind of sample would this be? Convenience, assuming they're available, right? Because say we did the class and I chose the first 10 people from the class list. You're here. You're convenient. I can do that real easy. Yeah, Luke?
I have another thing.
Okay.
If you made the list, then you could have put like your 10 favorite people on it.
Right, yeah, you could have had bias when you created the list.
It
Yeah.
it doesn't really have to do with this. But when are we gonna finish our Unit 13 masters?
I haven't even gotten a chance to look at them, dude. Yeah, I was gonna grade them partial. Maybe tomorrow. If I get to them tonight, maybe. My whole family's coming over tonight for dinner at my house, so yeah. My sister's in town right now, and she flies out tomorrow morning. So my whole family's coming to my house tonight for dinner. So I don't know if I'll get anything done.
Okay.
It's like when I say, hey, if your assignment's late, I know you had a game. I know you had give me a little bit of time. But thank you for asking. I know. I appreciate that you're aware that that needs done. So either tomorrow or Monday, probably. I don't know why you guys told him to shh. You gotta finish it at some point. All right, a movie theater wants to survey their customers and make sure they're maintaining a customer-friendly environment. You ever see those signs that say, like, if this facility needs attention, please let us know? Those sort of things.
Or keep Columbus great, and then there's like a sewer and there's like
Yeah.
trash.
So, which sampling description is an instance of systematic sampling? So, Thomas, you ask every moviegoer that walks into the theater. Is that a systematic sample?
No, that's convenient.
Well, it's convenience, but also, would you get a sample if you asked every person?
Yeah.
That'd be the population.
You'd get the entire population.
Oh, yeah.
So it's not a systematic sample, and it wouldn't even give you the sample. You'd be asking the population. If you asked every single person, you'd be taking the whole population. Ethan, you choose one customer that comes into the theater.
No.
Is that a sample?
Well, yeah, sort of, but it's the subject.
Yeah.
And that person, maybe the first time they're going, or whatever. It's just too many variables, I guess.
Yeah, so if you want to have all the details on here, number 1, you ended up with the whole population. Number 2, you only asked a subject. So we're not doing too hot here. Starting with the first moviegoer, Isaiah, you choose every 5th moviegoer that comes into the theater. Is that systematic? Yeah, because I have a start point. My first moviegoer is my start point, and then every 5th, my interval is 5. So yeah, number 3 is good. So number 3 is a systematic. And then, Brennan, you select the first 20 customers that walk into the theater. What would that be? It's not systematic, but it is. Somebody said it. It's convenience. Number 3 is the only systematic sample there. I always think that goer looks like a weird word. G-O-E-R. Anyone else think that?
Yes. Go faster. Go faster.
Words where you have 2 vowels right next to each other sometimes make your brain like, yeah, you don't often.
Words with A-E.
Weird. You know how I before E, except when you spell weird, W-E-I-R-D. Weird is weird. Ha, ha, ha.
Oh, yeah, I get it.
All right, Karina. How are convenience and systematic samples similar or different? You can choose whichever one you want.
They're different because they're different.
Obviously, different words, different methods. Is taking a convenience sample easy?
Yes.
Yeah, I don't have to make any choices. I just stand there and I choose every fifth or every second or every whatever. So they're the same or similar because they're both easy. Any other similarities anyone can think of between convenience and systematic samples? Bless you. What?
It can both be like available sometimes. Like
Yeah, hopefully. Well, convenience has to be available, and systematic. If you have a system of choosing people, sometimes they're available, sometimes they're not. So, say I have a list of Phoenix students. I choose every fifth student. They may not be available. I might have to go find them. I might have to go look for them. So that would be a little bit more difficult. So different, I guess we could say different is if they're available. Are the people that you've chosen available? They might be, they might not be. Layla?
I have a similarity. They're both probably random.
Ooh. So depending. Let's say I'm sampling what time do you get up in the morning, and I sample the first 10 people that walk into school. Do you think that would be random?
Nope.
Because if they were the first 10 people to walk into school, they probably got up early, or so it could be a similarity depending, but it could also be a difference. So I'm just not even going to put that up there because it could fall into either. I agree that could be a similarity between them. Systematic samples are random. You did not choose people. Hopefully you accounted for bias. And one thing that I can do, what if I choose every second, or let's say I choose every fifth person, and I end up with all girls? And I know that my population, girls and boys.
but it's true.
How? Well, I agree. So I chose it system. But could I go back and do something to try to get a different sample and account for that? Every what? Yeah, I could try every fourth or every third. I could change my interval and get another sample. Or you could take that original sample and take a new one and then compare the two samples with each other. So that's what we do a lot of times too. We could keep going, and actually I'll just show a list of some of them. So does it produce a sample? Yeah, they both produce a sample. Are they representative? Systematic may not be representative. I could systematically choose all girls by accident from a population that's girls and boys. Require knowledge of the population size. To choose my interval, I need to know how big my population is. If I'm doing convenience, I don't care how big the population is. Time and effort. Systematic will take more time and effort. Convenience is easy. It should be done quickly. Requires picking numbers at random. Convenience sample, no, nothing's random. You're saying, hey, you 10 people, come here. Systematic is, hey, you, 1, 2, 3, 4, hey, you, 1, 2, 3, 4, hey, you. It takes more time. It requires picking numbers. So there are similarities and differences there. Moving on. So we want to estimate how often books in the science section of the library are checked out. You decide to sample 9 books in the section. Choose a systematic sample. Is your sample a representative sample? So, anyone think they know how to do this? I have 72 books in the section. I want a sample of 9. Yeah, Crystal? Yeah, so to find my interval, N will be the population size over the sample size that I want. So my population here is 72. My sample size that I want is 9. I choose every 8 or every 8th book. Does it matter where I start?
Yeah. No.
Not really. I could start on the first one, the second one, the third one. Could I start on the 10th book? Then you would have missed the second book. So when you start, your start has to be at or below your interval size. So we have to start at 8 or below. So you want to notate that so that you know we have to start at 8 or below. I can almost guarantee there will be a question on your homework that asks you, like, with an interval size of 5, could you start with, item number 7? And you have to say, well, no, because I would have missed one already. Now, would this be representative? Is it random? It is random. If you think back to our similarities and differences, will a systematic sample always be representative?
No.
Not necessarily. So when we talk about this, they decide my starting number can be really anything, right? Because we're talking about books and we want to talk about how often they get checked out, this is likely going to be representative. It may not necessarily be, but in all probability, in all likelihood, it's probably representative. Because I'm choosing books randomly. I'm not saying, let's choose all the volcano books. Let's choose all the natural weather disaster books. I'm just choosing systematically this book, that book, that book, that book. And then I look at how often they got checked out. Questions on this? Can books have a bias? Yeah, kind of. If I choose all the volcano books, those have a bias. But if I systematically chose the books, and if they were cataloged correctly, I should have a representative sample. It should be pretty random. Suppose you want to determine how many students in your grade had a dream about flying. You ever wake up when you hit the ground in your dream? That's the worst.
I dreamed that I was flying a jetpack.
So, suppose we have 340 students in your grade. Suppose if, did I cut that out of your notes or did I leave the 340? Okay. On one set of notes, I cut them out and we fill in the Phoenix info. Describe how you would choose a systematic sample of 20 students in your grade. So, already talked to you, Bela. If I want my sample size to be 20, and I know I have 340 students, how do I determine my interval? So my interval n is going to equal something, and I can do some math to determine how big it is. If you need to, you can phone a friend, you can...
I'm your friend.
340 over 20.
Now tell me first why you did that. What over what?
It's the population over the sample.
It's the population size over the sample size that you want. So we take the whole population, 340, over 20. What can I do with stacked zeros? Get rid of them. So really, this is 34 over 2. What's 30 divided by 2? 15. 4 divided by 2. 2. Put them together. We get 17. So we're going to sample or choose every 17th student. And we could start anywhere below 17 or at 17. Questions on this? Does it seem pretty straightforward? You get how we choose the interval size? Understand why we have to start at or below it?
Yeah.
No questions at all? So when would a systematic sample maybe not give you a representative sample? I already gave you one example. If my systematic sample accidentally chooses all girls and my population is girls and boys, when else? Thomas?
It can be lined up so that it's all one thing.
Yeah, if I was like a gym teacher and they know how I choose my students and they came in and they lined up specifically, then that would not have a representative sample, Isaiah?
Like if you choose off of a list and you made that list, so you, like all your friends are.
Yeah, if I choose from a list that I made, yeah, that wouldn't be very fair. Like, and I thought about how I was making it. If I made the list at random, or used an alphabetical list or something that I didn't determine, then that takes out the bias. Any other? Yeah, Cassidy?
If you're at a dog park and you're walking your poodle and you choose all the poodles, that's biased.
Yeah, but that would again have to be accidentally, like from, say you chose every third dog and every third dog just happened to be a poodle, then that would not be representative unless it was a poodle dog park, and then okay, it does represent the population. If it's all poodles, then okay, your sample can be all poodles.
Like if you were in gym class and like the gym teacher said that you're gonna do like the soccer unit today, and all the soccer players lined up every other.
So they ended up on the same team. Yeah. So a systematic sample may not be representative when there's some sort of pattern or trend from in the sample from the population. So say the population, every fifth person has a certain characteristic. I would not want to choose every fifth person. I don't know necessarily what that characteristic would be, but if a pattern or a trend appears, that's a bias. So we're looking at Christmas lights. You were talking to your dad, and your dad says, these Christmas lights look like they're all kind of the same color. You're like, well, of course they're not. That's, they're multicolored lights. So you want to estimate the number of purple lights in a light display. You decide to take a systematic sample of interval 5, starting from the second light. Now, of course, you can't really tell the color on your paper. You kind of can because they're shaded differently. Some are darker, some are lighter. So if you look up here, starting with the second light, so what is the first color that I choose?
Yellow.
Yellow, right? I'm actually going to come over here so I can zoom in a little bit.
Red.
Yellow.
Crap. All right, so we choose yellow. Then 1, 2, 3, 4, 5. I end up with another yellow. 1, 2, 3, 4, 5. I end up with another yellow. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Anybody? 1, 2, 3, 4.
It's a pattern. It's a pattern.
Why do you think it's making a pattern?
Because there's just a segment repeated over and over again. Just like that segment repeated.
How many colors of lights are there up there?
5. Yeah, 5.
There's only 5 colors of lights, right? Are they in order by color?
Yeah.
Yeah. So if I choose the same interval as the number of items, like different items, there's 5 different colors. My interval is 5. I'm going to accidentally produce an enormous bias. According to my sample, how many colors of lights are there?
Only
1. According to my sample, everything I've circled, there's only yellow lights in my sample. So according to that, I've got a yellow light display.
Cool.
Is that true? No. So this is a non-representative sample. So this is non-representative. So if we use this systematic sample, how many purple bulbs do you estimate are in the display?
0.
None. But that's because this is biased. This is not representative. Now, who has a suggestion for how I could make my sample representative? Oriana? You said every 7th? I'm going to show this real quick. So, you said every 7. They told me every 6. So let's go ahead and try an interval of 6. So they say interval of 6, starting from the second light. So I'm still going to start from the second light, right? But I only have this little bit of the strand. So on your notes, right down here, we choose every 6, starting from the second. So there's 1, 1, 2, 3, 4, 5, 6. So I get a sample that's a yellow and a green. And we want to estimate how many purple lights are in the display.
So far,
None again, right? Well, crap. Why doesn't this work? That sampling method is systematic. It's not making a bias. It's not like it is representative. Ethan?
because the population is too small.
This sample is too small because really, and notice that Ethan said the population's too small. If I only look at that little bitty strand, that's not the whole population. That's part of it. I'm told there's 300 lights in the population, but I'm not looking at all of them. So if we back ourselves up and look at the whole strand, let's check this out. Whole strand, right? Start with the second light. You don't have to do this, just watch what happens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Notice that now I start back over with another yellow. What do you think my next one's going to be? Another green. The next one is that blue that is 6 away. The next one is going to be that purple that's 6 away. The next one's going to be that red that's 6 away.
What's red?
Yeah.
Purple or red?
So, is this creating a representative sample? Yes. When I make a larger sample, it will give me accurate data. But again, this is where your sample size has to be big enough. Because how many purple lights do I have out of a... Well, how many total lights have I chosen for my sample now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of them are purple? 2. So I have 2 out of 10 are purple, or 1/5 of my 300. So really this is 300 divided by 5. I get 60. Our estimate would then be 60 purple lights, which this would be accurate now. Does that make sense?
Yes.
And if I'm correct, that is the end.
Oh, can we play my turn?
Wunderbar. We have like 3 minutes left. We can.
Yay, potatoes.
Do a mind trap.